In 2026, the Victorian Law Reform Commission released a report containing 30 specific recommendations for institutional adaptation to artificial intelligence. This document marked a shift in the Australian justice system. The period of theoretical debate ended, and the era of mandatory procedural compliance began. This institutional mandate requires a specific architecture to translate complex academic science into actionable governance. As shown here, inputs from industry precedents and experiential knowledge filter through a central think tank to create standardized compliance guides for the safety community. The strategic opportunity lies in AI's capacity to process vast volumes of unstructured telemetry. By sifting through thousands of hours of media and data, these systems can identify predictive hazard patterns that would remain invisible to human observation alone. We see these touchpoints appearing across the entire evidence chain. Algorithms are now triaging latent fingerprints, resolving complex DNA mixtures, and performing rapid CCTV analysis, identifying specific vehicle models in seconds. However, this integration creates a fundamental tension. Relying on automated systems risks eroding human accountability and introduces significant legal liability if the underlying logic of a decision is hidden from the court. To manage this, WHS practitioners must move past legacy safety models. The new core competency of the profession is the ability to distinguish exactly where technology ends and human accountability begins. AI must be engineered strictly as an augmentation tool for human intellect. This requires an architecture where every algorithmic insight is verified by a person who can testify to the specialized knowledge used to reach a conclusion. The operational risk continuum clarifies this distinction. On the left are built systems, predictable frameworks where code is transparent. These contrast cultivated systems, like generative AI, where intelligence grows internally, creating representations unknown even to developers. This creates the black box problem. Because these computational pathways are effectively unauditable, they cannot be used to meet the transparency requirements of a modern courtroom or safety audit. Technical opacity creates a legal vacuum. If a safety professional cannot explain the internal logic of the tool they used, the evidence derived from that tool becomes legally hollow. This was the outcome of the Cosette dispute, where a court actively rejected an AI-generated forensic report. Because the internal knowledge of the algorithm could not be verified, there was no human expert who could legally testify to its specialized derivation. Under Section 79 of the Evidence Act, expert opinion must be based on specialized knowledge. Without a human who can verify the underlying science, the machine's output has no standing in the eyes of the law. Using opaque algorithms without a human verification layer introduces a fundamental failure point into the hazard control chain, rendering any resulting safety decision indefensible. The necessary strategic pivot is for the professional to become the technical gatekeeper, standing between streams of automated data and operational reality. The gatekeeper serves as an immovable filter, preventing unverified AI insights from triggering side actions until cross-checked against real-world context. This gatekeeping is governed by 8 ethical pillars. While they cover a range of requirements from fairness to transparency, every pillar is anchored to a central requirement: meaningful human control. Pillar 4 requires the absolute minimization of personal data collection, protecting sensitive telemetry from unauthorized ingestion into broad learning models. Pillar 5 focuses on reliability and safety, moving away from protecting proprietary black box secrets toward demonstrating transparent field error rates. Practitioners must also distinguish between investigative triaging and evidentiary analysis. Low-risk tasks like filtering hours of blank CCTV can allow for broad AI use, but high-risk safety decisions require strict human validation. Integrating AI without these structural pillars violates both the legal requirement for meaningful oversight and the basic principles of human dignity in the workplace. These rules govern tools currently deployed on active worksites. They are the operational reality for professionals managing heavy vehicle compliance and proximity detection today. Consider AI camera systems used for load restraint verification and registration checks. These systems process data at a scale that human observers cannot match. However, the camera only decides what is seen. The system only decides what gets flagged. A human gatekeeper must still verify the alert to ensure the system hasn't been triggered by a false positive, such as a piece of equipment being misidentified as a person. We see similar dynamics in conversational AI tools like RiskTalk. This system records pre-work briefings to analyze the quality of the safety conversation. Beyond checking for compliance, the tool can detect subtle emotional cues like uncertainty or doubt. It provides a score for the briefing, giving supervisors immediate feedback on the team's mental state. There's a documented digital bias, where people trust a digital readout more than an analog one, simply because it offers more decimal places. This creates a false sense of accuracy. Automation bias occurs when a professional stops critically checking the system's logic because the machine's output looks precise. Relying on the tool's apparent intelligence without active verification is the primary failure point in modern safety management. The robustness of this framework is tested during the inevitable collisions between automated dictates and frontline reality. A common dilemma occurs when an AI flags a hazard control as necessary, but experienced workers disagree based on their direct knowledge of the site's physical environment. Pillar 7 establishes a mandatory pathway for human review. Workers possess an irrevocable right to contest an algorithmic decision, ensuring that frontline experience can override a software-generated score. During these disputes, the AI's output must be classified strictly as a probabilistic assessment. It is an estimation based on patterns, not an established operational fact. There is also the obligation of disclosure. Whenever an algorithm influences an incident analysis or a shift allocation, that involvement must be formally documented. Absolute disclosure is mandatory for institutional transparency. Clear record-keeping must indicate whenever an AI-generated probabilistic assessment was used to reach a safety outcome. This transparency is the only defense against model decay. AI updates are often invisible, and a system's effectiveness can degrade as the original training data drifts away from the evolving reality of the worksite. Structured contestability and absolute disclosure are functional necessities. They ensure the hazard control chain remains grounded in verifiable evidence rather than unchecked algorithmic predictions. These processes resolve the ultimate question of accountability. When a safety system fails and an incident occurs, the question of liability is immediate and inescapable. Duty of care cannot be outsourced to a developer or a software package. The organization and the individual safety professional retain full liability for every outcome. In a legal setting, the argument that the AI recommended the action is an indefensible position. The professional must be able to justify the decision based on their own expertise. To manage this responsibility, we utilize the target operating model, the AI Human Conclave, a workflow maximizing processing power and accountability. Step 1 uses the data lake, where AI processes unstructured data to identify weak failure signals. Step 2 ensures probabilistic insights are subordinated to human intuition. Data informs the expert, it doesn't replace them. This synergy is foundational. While algorithms can reach near-perfect accuracy, they make fundamentally different mistakes than human examiners. Combining the two provides the highest level of reliability. AI provides the scale of triaging, while the human provides contextual reasoning. This interlocking defense mechanism ensures that the blind spots of the algorithm are covered by the professional's judgment. The professional must remain the ultimate arbiter, acting as the technical gatekeeper to protect the heart of the safety system from automated error. The highest level of reliability occurs when automated processing is anchored by human verification. This synergy ensures the technology functions as a decision support tool, keeping legal and operational accountability where it belongs, with the professional.